Hi, it's Jocelyn. So I'm about to do Advent of Code Day 7. I just messed up the audio on this one, so I'm going to try recording again. Fortunately, this one's pretty short. So I download my input. It's a single line of comma-separated numbers. And what is the problem? So there is a giant whale, and the crabs have rescued us from the giant whale. We have a, and they're bringing us underground. There's a horizontal position of all the crabs, and we need to get them all to the same place. So how do we get them all to the same place? And it takes one movement, or 1 point per movement of each crab. So how do we get them to the same place? We just move them to join at any position. So my first guess was probably that we wanted an average, but that's not necessarily the least total movement. So it's easier to just brute force it. So let's get started. So we have our crabs is equal to input.trim.split on commas. We're going to map the crabs to numbers, and then we're going to collect them. So that's going to be a vec I32. And so we're going to brute force. We're going to try all the positions and see which one's best. So the min position is equal to crabs.iter.min.unwrap. Unwrap because there's not necessarily a minimum if the thing is empty, and the same for max. And then we're going to look for the best. And the best is equal to, at first, the worst possible number, which is 64 max, and then we're going to go from min to max and see what we get. So best, so let's see, so the score starts at 0, and then we're going to go through all the crabs. So for crab in crabs, score plus equals, and then just the distance to the position. Meeting point in there, crab minus meeting point dot absolute value. And then we're going to say best is equal to best.min score, and then we're going to return the best score. And let's see if that works. Right, 1, 2 is I, 64 is everywhere. And one day I won't make this mistake, but we need to dereference min and max, because for types other than numbers, that would be reasonable, but for numbers, there's no reason to use a reference. All right, and we have an answer. And we see over here, again, I solved it, I messed up the audio, so we have our answer for there. So let's go on to part 2. So they don't seem interested in proposed solution because we misunderstood how crabs work. The first step costs 1, the second step costs 2, the third step costs 3, and so on. So that's what we're going to, so we just need to do mostly the same solution. The difference here is just in how we compute the score here. So there is a formula for like these numbers, 1 plus 2 plus 3 plus whatever, and we could do that. So we could do score plus equal, or yeah, there's the difference. So delta equals this, and it just so happens that that thing I know by heart is delta times delta plus 1, I think, divided by 2. So like if we're doing the first one, it's 1 times 2 divided by 2, which is 1, that makes sense. If we're doing the second one, that is 2 times 3, which is 6, divided by 2, which is 3, which is right. And I just assumed that I'm remembering correctly if the first two numbers are correct. So let's try part B. Oops. If I didn't remember this, like this formula here, that's fine. You can just compute that manually fairly quickly. And yeah, I see that number is correct. Anyway, thank you for watching, and I'll see you tomorrow.